Okay, folks, for this next section, speaking of vectors, we want to be able to get you ready for your third problem set. And so what you've been able to do so far is you've been able to take a vector, say 4, 7, and you've been able to produce then both what the magnitude is as well as the angle. The question is, suppose you're given the magnitude and the angle, could you go back and find the vector? And so we're going to have to come up with a slightly new formula for that. And it's a little bit different than what you've seen, but you're going to do a great job with it. As you can see, if I have vector AB, I am over A units and I am up B units. And you learn that if I want to find theta, I simply take the tangent of theta and set equal to B divided by A. If I want to know the magnitude of the vector, I take a squared plus b squared and do the square root. Well, what if you're not given a and b? What if you're given the magnitude and the angle and you like to find a or b? Well, we need a trigonometric relationship that relates those things together. So, think of the magnitude of the vector and theta and a. If you notice, it's part of a triangle. Which trigonometric function has to do with the angle and the adjacent side and the hypotenuse? And if you said cosine, you're right. In fact, we would say that the cosine of angle theta is going to be equal to a divided by the magnitude of the vector. If you simply multiply both sides by the magnitude, you get the magnitude of the vector times cosine of theta is in fact equal to a. So just like in the last video, I had a couple formulas that are really important for you to write down. These formulas are important for you as well to write down right now. So that one, and if we switch it, suppose we want to find b, you have theta, and then you have the angle over here, or the side over here, which is opposite. So which trig function has to deal with the angle on the opposite side and the hypotenuse? Opposite hypotenuse would be sine. Very good. So the sine of the angle is equal to the opposite side divided by the hypotenuse. So b divided by the magnitude of the vector. So I have sine of theta is equal to b divided by the magnitude. If I multiply both sides by the magnitude, I get the magnitude of b is equal to, magnitude of b times the sine of theta is equal to b. So if you want to be able to find a and b, you just set that up. Okay? So we're going to do 3 examples together, and then you're going to be ready to go to work on your own with that. So let's do these 3 examples and make sense of all of it for you. So we have the magnitude of the vector is 6 and the angle is 60 degrees. So what that means is, suppose that that's my vector, where that's the length of 6 and that angle is 60. What you want to be able to do is find A and find B. Well, instead of going through all the work of the trig setup that we had before, let's just use the formulas that we were given. A is equal to the magnitude of B times the cosine of theta, or 6 times the cosine of 60. Now here's where, if you could write it in simplest radical form, you want to make sure you do that. And for a 60-degree angle, you should know that that creates a terminal point of 1/2 and root of 3 over 2. 1/2 and root of 3 over 2. Cosine is the x value, so we have 6 times 1/2, which is 3. For b, we do the magnitude of the vector times the sine of theta. Well, the magnitude of the vector is 6, and sine of 60 is going to be the y value of the terminal point, or the root of 3 over 2. 6 divided by 2 is 3, and you get 3 roots of 3. So, what is the component form of the vector that has a magnitude of 6 and an angle of 60? We say that the component form is 3, 3 roots of 3. So we went backwards. We went the other way. Given the magnitude and the angle, we found the component form. So the component form is just another way to graph it. Component form is nice because we can add it, we can subtract it, we can do all sorts of things. So coming up with that is really critical. Okay, so there's one example. We'll do two more. Okay, so we know that in order to find A, we take the magnitude of the vector times the cosine of theta. So we have 10 times the cosine of 135 degrees. 135 degrees is going to be in the second quadrant. And you notice that you have a 45, 45, 90 special triangle. So hopefully you know that that terminal point that it reaches then is going to be negative root of 2 over 2 and positive root of 2 over 2. So cosine is going to be the x value, so 10 times negative root of 2 over 2, I get negative 5 roots of 2. B will be the magnitude of the vector times the sine of theta, or 10 times, now we use the y value, root of 2 over 2, and we get 5 roots of 2. So therefore, the component form of the vector is negative 5 roots of 2 and positive 5 roots of 2. And there's your vector component form. That's example number 2. As you notice, our first two examples came out really, really nice because we had exact values for terminal points. In that case, you need to come up with the exact radical form, okay? No approximations. But what about this? Suppose you have a vector with a magnitude of 24 and theta is equal to 322 degrees. Okay? Well, 322 is not an angle that we have exact values for the terminal points for. So, if you think about the graph, 24 and 322 degrees, it'll be something like that. Okay? And it's not 315, it's not 330, it's not 300, it's 322. So all we can do is just say we have the magnitude of the vector, A is equal to the magnitude of the vector, times the cosine of theta, or 24 times the cosine of 322 degrees. So I can't come up with the exact value. I need to come up with it on my calculator. So I do 24 times the cosine of 322, and I get 18.91. In order to determine B, I take the magnitude of the vector times the sine of theta, which is 24 times the sine of 322 degrees. Calculator 24, sine of 322, and I get negative 14.78. Now, I'm just going to do a small check here to verify my answer because I came up with a negative result. And is that really a good idea? Well, it is, because if you were to plot this graph, 24, 322 degrees, you can see that 322 degrees places you in the fourth quadrant. If you're in the fourth quadrant, you know that you're going to come up with a positive x value and a negative y value. If you get a positive x value and negative y value, that corresponds to what I have here. As you look at it, the way you sketch the angle, it looks like the x value should be greater than the y value, and in fact it is as well. So use some reasoning with your graphing. Sometimes people say, do I have to graph it? Well, no, I guess you don't. You don't have to draw it out, but you should always be able to graph it in your brain and be able to do that check. That's one of the great things that excellent mathematicians are able to do, is be able to do those checks. So that takes you through problem set 3. It's great to see you guys again. Remember, if you need any help, please reach out to me. I get lonely. I would love to help you Mondays through Fridays. I usually have plenty of time to be able to connect with people. So have a good one. Be a great Tiger. Enjoy your week. Later.